In this lesson, we're going to learn about something called the standard form of a quadratic function. Now, we've already covered what's referred to as the general form. The general form is ax squared bx and c. Remember that a quadratic has the degree 2, or x squared term. A can't be 0, otherwise that term won't exist, and we'll have a line instead. Some things that we should know from this form. First of all, the y-intercept is where x is 0. So substituting 0 for x, we see that the y value is that number c. So this form is very easy for helping us find the y-intercept. The direction of opening is also easy to see. It's based on the a value. When it's positive, we open upward, and when the a value is negative, we open downward. You can check that by substituting some points into a graph or looking with your graphing calculator. The way to graph general form is this method here. We start with getting the y-intercept. That's where f of 0 is. We just talked about that, x value of 0. Also the x-intercept, that's where f of x, or the y value, is 0. Consider the axis of symmetry. If we found two x-intercepts, we know the axis is the mean value between them because of symmetry. We also know that the vertex is on the axis of symmetry, so it shares the x-coordinate. We can put the x-coordinate into the equation to get the y value. And if needed, we can pick some extra points by choosing x values and substituting to get the y values. Then we plot all the information. Now there's a new form that's very valuable. It's called standard form. The a is the same as before, so the a is still telling me the direction of opening. But there's something new introduced here, an h value and a k value. The h value is next to the x, inside of a bracket being squared, and k is being added or subtracted on afterwards. So just a reminder, in this example over here, with an a, an h, and a k, that negative sign is telling you a is negative, so it opens downward. Now, let's consider something more of the form of standard form and see what we learn from the h and the k. First of all, we're going to look at this h number. Let's consider y equals x squared, y equals x plus 2 all squared, and y equals x minus 1 squared. For these ones, observe that the h value here is actually negative 2 because of that negative sign that's in the rule. This must be subtract negative in order to make a plus 2. This h value is positive 1. If we graph these three with a graphing calculator or software, we would see these three graphs. The bold one is y equals x squared. The one where h equals negative 2 is actually this graph here that has translated, which means moved, to the left. So if the h value itself is less than 0, we move left. If the h value is more than 0, like this one, we see that we've actually moved to the right. This graph is this third one that's over here in the first quadrant as it moves up to the right. We can also see that the vertex can be identified from the h value. So the h value is the x-coordinate of the vertex. That's the value of the h in standard form. Now let's look at the k value. Got some other graphs here. Y equals x squared again, our reference, simplest quadratic. X squared plus 1 and x squared minus 2. Notice here that the k value is positive 1, and here the k value is negative 2. If we graph these three together on a graphing calculator or a software program, we see this. Y equals x squared, the bold one again. X squared plus 1 is 1 unit up, and x squared minus 2 is 2 units down. So this is a translation up or down. And if the k number is more than 0, like this one, we move up. If the k number is less than 0, we move down. Another point of observation here is that the vertices, in this case, are all on the y-axis, So the k value is showing us the y-coordinate of the vertex. So if the h value gives the x-coordinate of vertex and the k value gives the y-coordinate of the vertex, then h comma k taken together is the vertex of the parabola, which is a very important point on a parabola because it determines the max or the min location. All right, here's some problems. We're going to see how well you do at learning from what we just talked about and applying it to these situations of these three parabolas, all in standard form. You may want to pause and try to fill in this chart of vertex, axis, max-min value, and range, and then see how you do. The first one has an h value of 5. That minus sign is part of the definition, so it's not minus 5, it's plus 5. K value is minus 3. The axis is a vertical line, so it's always x equals, and the vertex is on it, so it's x equals 5. This opens down, so it's a maximum value. It's a parabola opening downward. The range, that's a reference to the y value. If I have a maximum, then y must always be less than or equal to the vertex value, negative 3. If that makes more sense to you now than it did a moment ago, pause again and try these next two now and see how you do. The next one here has vertex of negative 1, negative 2. Remember, this is always a subtraction, so when you see plus, that means we subtracted a negative number. The axis is the x-coordinate of the vertex. This one opens up, so it's a minimum problem. If it's a minimum, the y is always more than or equal to that y-coordinate of the vertex. This one's a little bit tricky because the values are rearranged, but observe something here. If I substitute this negative 1 in this bracket, the bracket becomes 0. Substitute 5 in this bracket, the bracket becomes 0. So considering that, think about an x value that will make this bracket 0. It needs to be 3. It's the signed opposite because the x and the number are turned around. The axis, x equals 3, it's that x-coordinate. This is a positive a. It opens up, it's a minimum, so the y is always more than or equal to that y value of 4. One other observation I'd like to make is finding the y and the x-intercept from standard form. Let's use y equals negative x minus 5 all squared minus 3. Now remember, the y-intercept is where x is 0. Let's actually do that. Put 0 in for the x-coordinate value and simplify. The bracket's negative 5. It's squared. That's 25. So I get negative 25 minus 3, negative 28. So the y-intercept is actually 0, negative 28. Many people think it's the negative 3 value. It's not. It's not this number in standard form. It's this number when you're in general form. One more thing, the x-intercept, that's where the y-coordinate is 0. So to find the x-intercept, I need to solve this equation. To solve for an unknown value, we want to isolate it. So if I imagine taking this binomial bracket that's negative and moving it over to the left side of the equation, it's now positive by addition. Now, there's two things I can do here. I may get rid of squaring by square rooting. So the left side is now x minus 5. The right side will need to be either a positive or a negative result, because remember, a positive thing squared gives a positive result, and a negative thing squared gives a positive result. So there's always two roots. So it's plus or minus the root of negative 3. But wait, we can't take the square root of a negative, so this is not defined. There are no values, and what that means is there are no x-intercepts. Remember, we learned before there can be none, 1, or 2 x-intercepts. Here's another observation you could have made. At this line here, you could have said a square, left side, cannot equal a negative number. Not for real numbers, so there's no solution to this. One more observation is let's use our new knowledge about this graph and the vertex, and let's plot 5, comma, negative 3. There's 5. There's negative 3. There's our vertex. I see a negative sign, so I know this opens downward, like this. And we can see there's no x-intercept, because the x-axis is up here. There you go. That's the basics of standard form. Good luck with the lesson.